Ladies and gentlemen, up until now, we've been solving equations, quadratic equations, okay? How do we solve quadratic equations? We would factor, split it, and solve. The only difference on today's section is that we're going to be solving polynomial equations. So we might have a 4th degree polynomial that we're solving, a 6th degree polynomial, who knows, higher degree polynomials that we're going to be able to solve. And we're going to do it the same way as solving quadratics, which was factoring, splitting, and solving. So to begin this section, we have to review all these different factoring methods. Now, I'm not going to take that much time on reviewing these factoring methods because we should know them already. There's a couple of them that are kind of new to us. There's one that I'll show you how to do in an alternative way of factoring by grouping, but we'll get to that all in a bit. Right now, I just want to let you know that you should know how to factor, okay? If you don't know how to factor, I would go back and watch previous videos that cover these notes. These actual notes are from a previous section from last semester. So we should all know how to factor by pulling out a GCF. Should probably done that in yellow. Pulling out a GCF, right? So you look at what's in common. Oh, there's a 2 in common in both 2 and 6. Not only that, there's both an x squared in the second one and an x squared in that one. So you could actually pull out the GCF of 2x squared. I hope we all remember that. Yay? Okay, GCF, very important. That's the very first type of factoring that we learned back in Algebra 1. This is the very first type of factoring you should always attempt. Try to pull out a GCF. All right. We also covered factoring by grouping. Factoring by grouping. And that's where you have 4 terms. You split the first 2, the second 2. You pull out what's in common. So there's obviously an x squared in common from the first group. What's left over, an x and a 1, right? X squared times x is x to the third. X squared times 1 is x squared. And right here, since there's nothing to pull out, because we're doing factoring by grouping, we forcefully pull out a 1, which is kind of ridiculous because you have the same thing left over. But the important thing is that you recognize that there's a common binomial, x plus 1 in the first group and x plus 1 in the second group. So you take these common binomials and you pull them out to the front, which means you would have the x plus 1 out here in the front, which means you'd have the x squared left over and the 1 left over. The x squared comes down, the 1 comes down. Notice that there's an exaggerated parenthesis, so you could see what's missing. You could see what's missing. What is missing? The x plus 1 that we pulled out to the front is missing. So these are exaggerated parentheses, so you just write them the correct size, and there's your factored form answer. I hope we remember that. If you don't, it's okay, because we will be learning alternative methods. Factoring a quadratic trinomial when your a value is 1, that's really easy. All you do is think what times what is c, that if you combine together is b. So right here, we're thinking what times what is 6, that if I combine together is 5. That would be 3 times 2. 3 times 2 is 6, and 3 plus 2 is 5. So again, whenever you have a quadratic trinomial where your a value is 1, you set this up. You set up parenthesis, 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 xx. And once you think what times what is your c value, that if you combine together is your b value, you'll be able to plug in those numbers. We said positive 3 and positive 2. That's why factoring this quadratic trinomial gives us this binomial times binomial, right? Maybe I should have started with this. I hope we all remember what factoring is. It's a reverse distributive property. It's doing distributive property backwards. So if I were to distribute this binomial times that binomial, it should give me the quadratic trinomial that I was starting to factor in the first place. Okay, why am I rushing through this? Because we should all know this, right? We should all be like, hurry up, Salgado, get on to something I don't know, because we should all know how to factor. Factoring completely, pull out a GCF first, and then continue factoring, right? This was an interesting section. Factoring a standard form quadratic trinomial when your a value is not 1, when you actually have a number right here. Okay, now I hope we remember this. This was probably the most challenging type of factoring. Step 1 was to multiply a times c and get an answer. Step 2, think of the multiples of that answer that combine together to give you the b value. And tip, make a list. Step 3, use that pair of numbers to rewrite the bx term changing it from a trinomial to a polynomial. That way you could factor by grouping, okay? So maybe instead of just reading, let me cut one of these out and then do that problem together. So let's take this guy and let me put it down here next to these steps. Okay, so step 1 is to multiply a times c, that's 6 times 3, which gives me negative 18, right? A times c. Step 2 is to think of the multiples of this answer, negative 18, negative 1 times 18, negative 2 times 9, negative 3 times 6, negative 4 doesn't work, negative 5 doesn't work. Those are all the possible ways of multiplying two numbers together to give me negative 18. Now, which pair of numbers combines together to give us the middle value b, which is negative 7? That would be the negative 2 and positive 9. However, negative 2 and positive 9, when I combine those, that gives me a positive 7, not a negative 7. So I have the right number, I just have the wrong sign, which means I have the right numbers, I just have the wrong signs. So I'm going to make this a positive 2 and a negative 9. So that's the actual correct pair of numbers. Are you guys with me? Do you guys remember this? Okay, some of us are saying yes, that's good. And then step 3 is where you jump to factoring by grouping by changing your trinomial to a polynomial. This is where it gets a little weird. You have the same a value, or the same first term, 6x squared, but instead of the middle term being negative 7x, we're going to rewrite negative 7x as positive 2x minus 9x. Okay, we're going to rewrite it as positive 2x minus 9x. And then, of course, we still have the minus 3. Let's put the minus 3 at the end. And now we have 4 terms. And you're thinking, why the heck would I want to change 3 terms into 4 terms? This way, now you could apply factoring by grouping, which is a whole other process in itself. Do you guys remember this? Okay, now I could continue right here factoring by grouping. But I'm not. I'm going to show you a different method. I mean, if you're already good with factoring by grouping, yeah, go ahead, factor by grouping, and you'll be able to factor it. But let me show you this like magical shortcut, all right? Here's the magical shortcut. It says, or you could use the magical shortcut to factoring quadratic trinomials when a is not 1. Now, the same 2 steps are here. Step 1 is exactly the same. Multiply a times c, get an answer, okay? Step 2 is exactly the same. Think of the multiples of that answer that combine to give you the b value, make a list, right? Same stuff as before, but here, instead of doing step 3, making it a 4-term polynomial where you have to do factoring by grouping, instead of that, this is where it gets interesting. Step 3 is where it gets interesting. It's an alternative route. Step 3 says, write your factored form answer format like this, parentheses, and notice it says ax. ax, okay? So look, once again, step 1, a times c. We said that was negative 18. Step 2, think of the multiples of negative 18 that combine together to give you the middle value b, negative 7. And we said that was negative, what was that? Negative 9 times positive 2. So instead, yeah, negative 9 times positive 2. Of course, make a list if you're struggling with that. Now let's go back to step 3, magical step 3. Magical step 3 is to write your factored form answer format, and in the parentheses, in this spot right here, put ax. What is our a value? Our a value is 6, and we're going to put it with a single x. So we're going to put 6x and 6x. ax, in this case, a is 6, and x is x, so 6x and 6x. Now, I know you're thinking, what the heck are we doing? We're just writing 6x? Yeah, and you know what? Guess what? That's wrong, right? Because 6x times 6x is 36x squared, not 6x squared. But don't worry, we're gonna do a little magic trick to make it get back to the correct answer. All right, but this is what we're doing. We're putting the ax term right there, there it is, 6x and 6x. And now it says plug in your pair of numbers from step 2 into the empty spaces. So I'm going to take my pair of numbers from step 2, -9 and +2. -9 and +2, and just plug them in right there. Now, this is not our answer yet because we know that 6x times 6x is not 6x squared. It's actually 36x squared, so that would be wrong. I need to do something else, and this is the magical step. Whoops. This is the magical step 4 that I'm talking about. It says magically reduce. Even though it's not a fraction, it's kind of like reducing. Think GCF, each binomial if possible. Now, it's not a fraction, but I want you to kind of like pretend it was a fraction where you think, okay, what is the GCF of your first binomial? Is there anything in common with the 6 and the 9? Yeah, there's the 3. So we're going to magically reduce by 3. Even though it's not a fraction, we're just going to magically change that 6. If we reduce by 3, it'll become 2x. Reduce the 9 by 3, it'll become 3. Reduce the 6 over here on the second binomial, the 6 and 2, that's a GCF of 2. So reduce both by 2, and you'll get a 3x and a 1. And guess what? We're done. So instead of, in lieu of, after step 2, going to step 3, factoring by grouping, which you'd have to do 4 terms, which you'd have to separate it, factor from the first group, factor from the second group, and then factor the common binomial. Instead of doing all that, you could start your factored form answer format, parentheses, ax, ax. A is 6x, there it is, 6x, 6x. That's your ax term. Plug in the pair of numbers from step 2 right there, and then magically reduce. I say magically because it's not like you're actually pulling out a 3. You're not pulling out a 3 and writing the GCF 3 out here. You're not doing that. You're magically reducing. You're just canceling. 6 divided by 3 is 2, 9 divided by 3 is 3. Over here, the GCF is 2, so you're magically dividing. 6 divided by 2 is 3, 2 divided by 2 is 1. And ladies and gentlemen, this is your factored form answer. What do you think of that? It truly is a faster, it's a shortcut, okay? Now, if you love factoring by grouping, yeah, you could have continued down here. Right here, we did the same step 1, got -18, the same step 2, +2 and -9, and then we replaced the middle term, -7x, with +2x and -9x. Then you'd have to split the first group from the second group, pull something out of the first group, pull something out of the second group, and then pull out the common binomial. It's up to you which method you want to do, but I honestly think that the more we practice with this method of over here, it's a lot better, okay? Okay, so let's try this shortcut with this new example, 6x squared minus 1x minus 2. All right, it's this simple. Your a value is not 1, so you know you can't factor. Unless you use that multi-step method. So step 1 is to multiply a times c. That'll give us -12. Step 2 is to think of the multiples of that answer, -12, like -1 times 12, -2 times 6, -3 times 4. And that's all the possible multiplication to get -12 besides changing the signs. So when I start combining, this 12 and -1, that gives me 11. That's not 11, that's -1. 6 and -2, when I combine it, it gives me 4. That's not 4, it's -1. 4 and -3, that gives me 1, not -1. So I have the right number, I just have the wrong signs. So I need to change this to a +3 and a -4. Okay? Now let's jump to our magical shortcut method. Instead of making this a polynomial, 4 terms, that I could apply factoring by grouping by, instead of doing that, let me do what the instructions here tell us to set up my answer format with an ax right here and an ax right there. What is ax? Again, here's ax squared. You just want ax, the 6x. So I'm going to put a 6x right there and a 6x. Now, what if I would have had like a 4x squared? I'd put 4x and a 4x. If I had a 3x squared, I'd put a 3x and a 3x. Whatever your a is, just put an x right there. 6x, 6x. And then you take the pair of numbers from step 2 and plug them into those blank spots, the +3 and the -4. And now let's just magically reduce these binomials, okay? If you can. So could I reduce 6 and 3 by something? Yes, reduce by 3. So you're going to magically reduce by 3. That'll give you a 2x and a 1. 6 divided by 3 is 2. 3 divided by 3 is 1. And over here, the 6 and the 4, you could magically reduce those by 2. So 6 divided by 2 is 3 with an x. 4 divided by 2 is 2. And voila, we're done. That is your factored form of your original quadratic trinomial that had the a value of 6. Guys, I did not assign homework tonight besides to watch the video that I've already uploaded previously. So please watch that previous video that's uploaded on Google Classroom. Okay, let's move on to something more. Reviewing, whoops, what happened to that? Give me 1 second, guys. Here we go, guys. Some more review. What do I mean by more review? Difference of two squares. You guys should remember difference of two squares, where you have a perfect square term in the front, perfect square term in the back, minus sign in the middle. You just square root them and plug them into your answer format. I'm not going to spend much time on that. We should all know how to do that. For example, the answer to the square root of 25x squared is 5x. The answer to the square root of 36 is 6. So 5x and 6 on both binomials. One has to be a plus, one has to be a minus. Are we good? I hope. Okay. Right here, the square root of 49x to the 6th, that's 7. The square root of x to the 6th itself. A square root is really the power of 1/2. So when you have x to the 6th to the 1/2, that's 6 divided by 2, which would give you 3. Okay, so 7x to the 3rd is the first part of each binomial. The square root of 9y squared is 3y. 3y, 3y. And of course, you put 1 plus and 1 minus, or 1 minus, 1 plus. I hope we remember that. We are moving on. Now, what if I gave you this quartic trinomial equation that I asked you to solve? Up until now, we cannot solve that. However, we're going to learn a trick right now at the end of this class right here. When you have your degree being twice as much as the power of your middle term, you're going to be able to apply this method. Now, what is the method that I'm talking about? Being able to change a higher degree polynomial to look like a quadratic trinomial. Being able to change a higher degree polynomial to look like a quadratic trinomial. So, and I did it up here. Your new skill for this section is making a higher degree polynomial look like a quadratic trinomial. So right here, it's x to the 4th, but wouldn't it be nice if it was an x squared? Instead of minus 7x squared, if it were just a minus 7x. Okay, so if we had x's right here, instead of x squares, it would be nice. But before we do that, before we actually make it look like x's in there, what actual value must be right here in order for it to be the original x to the 4th? What has to be in here? Could somebody just unmute themselves and let me know? What has to be right here in order to, when you have a second power, that it becomes x to the 4th?
X squared.
X squared. Thank you very much. And over here, this is already an x squared. So right here, we're just going to put another x squared. So once again, you're going to be able to apply this trick when your degree, the highest power, is twice as big as the power of your middle term. Okay. Now, this is what might help some of us, where you take, I'm going to put a red x to represent that x squared. And I'm going to put this in a cloud. I want to take a red x to represent that blue x squared. Now, why would I do that? Just so it'll look like a nice, beautiful quadratic trinomial. Okay, this is a new skill, so everybody please be taking notes. Please pay attention. Now that it looks like a quadratic trinomial, how would you solve this quadratic trinomial equation? You would simply think what times what is negative 44, that if you combine together is negative 7. And you might have to make a list. Let me zoom in on this just so I could solve this new quadratic trinomial. I will have parenthesis, red x, and I need to think what times what is negative 44, that if I combine together is negative 7. If you want, make a list, but I already see that negative 11 times positive 4 will give me negative 44. Negative 11 times positive 4 will give me negative 44, and if I combine those two together, it does give me the b value negative 7. So what I've done is I've made it look like a quadratic trinomial. That way I could factor it, that way I could split it and solve it. X minus 11 equals 0. X plus 4 equals 0, which tells me that x equals positive 11 and x equals positive 4. Now, ladies and gentlemen, these are not answers yet. Why not? Because I originally replaced the blue x squares with the red x. So this red x is really that blue x squared. So I need to take the blue x squared and go back and replace those x's with x squares. So I really have x squared equals 11, and I really have x squared equals 4. Does that make sense? I hope it does. We have to have a high level of concentration here, all right? I still need to solve x. Say again? Somebody?
I may be wrong. It's not negative 4?
It's, oh yeah, it's negative 4. Hey, thank you so much, Jack. Thank you. I'm rushing through this. Yeah, that's a negative 4. I apologize. That's what happens when I don't show my work here. Subtract 4, subtract 4. Yes, that's definitely a negative 4. Thank you so much, Jack. Okay, so let's take these two equations, the x squared equals positive 11 and the x squared, thank you, Jack, you saved me right there, and the video because I'm actually recording this, equals negative 4. And let's solve both of them. How do you solve a quadratic? How do you get rid of a square? By square rooting. And when you do to one side, you do to the other. The only difference is you put a plus or minus in front of your answer. So you really have the plus or minus square root of 11 because you can't really do the square root of 11. Then over here, you square root, you will have x equals plus or minus 2i. So we actually have 4 answers to the original quartic trinomial equation. 2 of them are real, 2 of them are imaginary, okay? Now, where is the square root of 11 really? On a calculator, if you did it, it'll give you a decimal. Hey Siri, what's the square root of 11?
The square root of 11 is approximately 3.31662.
All right, so it's about 3.3, right? So that's an actual location, both positive and negative on the x-axis. If I were to graph this quartic trinomial equation and I was trying to find the x-intercepts, well, it would have 2 real x-intercepts. It would cross the axis, the x-axis at about positive 3.3 and negative 3.3. Now, over here, these are imaginary. That might mean that there's like a curve or a dip, but it never actually touches the x-axis, all right? So this quartic trinomial crosses the x-axis at 3.3 and at negative 3.3. So you have 2 real answers, you have 2 imaginary answers. In order to really understand this process, we're going to do another one. So please copy this one down. And again, it would be nice if I could change this to a quadratic so I could factor, split, and solve. And that's what we're going to do, okay? We have t to the 4th, and I could change it to look like a quadratic only because the degree is twice as big as the power of the middle term. So I will be able to replace the t to the 4th and make it look like something squared minus 21 of that same value plus 80. That way it looks like a quadratic trinomial that we have equal to 0 that we could factor, split, and solve. So what are we going to be doing here? Well, first of all, let's state what has to be in here in order for this to be a t to the fourth. What has to be in here? Anybody? Unmute yourselves and let me know what has to be in here.
T to the second power.
Thank you so much, Keith. T to the second power, right? So this is what we're going to do. We're going to replace a red X in place of those t to the second powers. And I want to put a little cloud around this. Very important that we remember that. If we forget about it, we're going to have the wrong answers. But we're going to replace the t squareds, the blue t squareds, we're going to replace them with a red x. So we'll have a red x squared minus 21x plus 80, plus 80 equaling 0. So now we could factor, split, and solve by putting an x there and an x there. So what times what is 80 that if I combine together is negative 21? Let's make a list. 1 times 80, 2 times 40, 3 times doesn't work, 4 times 20, 5 times 10, and then 6, that'd be 16. And I see that when I combine positive 5 and positive 16, it'll give me a positive 21, but I need it to be a negative 21, right? So I have the right numbers, I have the wrong signs. I'm going to change that to a negative, change that to a negative. So I plug these values in, minus 5, minus 16. We're going to split them and solve. So we're going to have x minus 5 equals 0, x minus 16 equals 0. Solve both. I will have a red x equaling, red x equaling positive 5. And over here, a red x equaling a positive 16. Now, those are not answers because I need to go back and replace what those red x's really are. And up here in that little cloud, it says that those red x's really are t squares, blue t squares. So I'm going to replace those blue t squares for the red x's. So we have a t squared equaling 5, and we have a t squared equaling 16. Let's solve these quadratic equations by applying a square root. You'll get t equals plus or minus the square root of 5, which is a crazy decimal number, about 2 point something. And over here, square root, t equals plus or minus 4, the nice actual number 4. So this one has 4 real solutions. This quartic trinomial equation, if I were to graph it, it will cross the x-axis at about positive 2.2, negative 2.2, and also at positive 4 and at negative 4. It'll actually have 4 real answers, 4 real zeros. And last but not least, this guy up here, right here, it is a higher degree. It's not quadratic, but you could think of it as a difference of 2 squares if you know that the square root of 625 is, what is the square root of 6? Hey Siri, what's the square root of 625?
I have results from multiple sports. Which one would you like?
Multiple sports?
Basketball, cricket, football, golf.
Are you kidding me, Siri? Okay, what is it? Anybody have a calculator? Hey Siri, what is the square root of 625?
The square root of 625 is 25.
It's 25. There you go. So we do have 2 perfect square numbers. So we're going to square root that, because the square root of 625 is 25. We will have the square root of m to the 4th is m squared. The square root of 625 is 25. 1 is positive, 1 is negative. We still have the equals 0. So I factored by applying the difference of 2 squares. Now we're going to split and solve. M squared plus 25 equals 0. M squared minus 25 equals 0. So you're going to have an m squared equaling negative 25. You're going to have an m squared equaling positive 25. Sorry, I didn't show my work there. Just get rid of those 25s, move them to the other side. Now we're going to square root. Square root, we'll have m equals plus or minus 5i. That's 2 imaginary answers. Square root, m equals plus or minus 5. You have 2 real answers, 2 imaginary answers. That is a total of 4 answers, which is appropriate because it is a 4th degree equation. Man, this has been a long lesson. I did record this. This is a long video. There is no homework tonight. I do need you to watch the previous video that I posted on Google Classroom. And that also has sum and difference of 2 cubes, a new method that we're going to be covering tomorrow. So please make sure you watch that. That's your homework. It's a long lesson. That's why I gave you no practice. I just want you to watch the video again. I will see you tomorrow.